This video is going to give us some practice with our exponent rules. So the first rule in this column is going to be that when we multiply terms with the same base, we add the exponents. When we are evaluating expressions with exponents, we want to first check that the bases are the same. For every single one of these questions, the bases are the same to begin with: 7 and 7, 3 and 3, 5, 6 and 5, 6. You'll see later in future videos that sometimes the bases are not the same to begin with, and then you have to express each number in terms of the same base, typically powers of 2 and 3 on the SAT and ACT, and what you'll see in your middle school and high school math classes. Okay, 7 to the 5th times 7 to the 6th, we have the same base. When you multiply terms with the same base, you add the exponents. So this gives us 7. I'm going to change this briefly to the 5 plus 6, all up in the exponent, and that is the same as 7 to the 11th power. Next one, 3 to the negative 3 times 3 to the 8th power. Our rule is if we multiply terms with the same base, we add the exponents. In this case, the exponents have different signs. The 3 is a negative 3, and the 8th power is a positive 8. When we have numbers with different signs and we're adding them, we get the difference of the numbers. Difference means subtraction, and that gives you 5. And then you keep the sign of the bigger number. In this case, that's going to be the 8. So therefore, your result is 3 to the 5th. Let's make some room here. Next, 2 to the negative 4 times 2 to the negative 3. Again, multiply terms with the same base, add the exponents. So that's going to be 2 to the negative 4 plus negative 3. Let's look at our number line briefly. So if we're adding negative 3 to negative 4, we're going to start, let's just say 1, 2, 3, 4. That's our negative 4. And we're adding negative 3, meaning we're continuing in this direction 3 more places. So it's going to be negative 5, negative 6, negative 7. So the result is going to be negative 7. We got that by adding negative 4 plus negative 3. When you're adding negative plus a negative, you're going to be moving in the negative direction, meaning to the left. So the value is just going to become more negative because you're moving further away from 0. It's becoming more negative. So this is a good strategy if you get stuck and you forget that. This one tends to trip students up because they don't recognize that these are the same base. You don't have to distribute the powers here. You don't have to distribute the 4 to the numerator and the denominator. Technically, that's allowed. It would create an equivalent expression, but that's not what they're looking for here. So the goal is to write this using a single exponent. So that's our direction, a single exponent. And therefore, you would just keep the base because you're multiplying terms with the same base. Let's keep it in parentheses. That's 5, 6. And then multiply terms with the same base, add the exponents. So this is going to be 5, 6 raised to the, in the exponent, 4 plus 5. So the result is going to be 5, 6 to the 9th power. In this column, we have questions asking us to raise an exponent to an exponent. I just want to highlight what that looks like. So take note of the structure. So you're going to have parentheses. That's a clue. But let's take note of one other structural pattern going on here. So notice that this exponent here, it's up high. There's a parentheses, but both of these exponents are up high. The base is down low, exponent's up high. In contrast, I want to show you a couple more of these, but then I want to show you in contrast a question that trips students up and they incorrectly think that the structure of the presentation of the information is the same. So let's just look at each of these. You got 4 to the 3rd raised to the negative 3, 2 to the negative 8 raised to the negative 4, 6 to the negative 3 raised to the 5th power. There's those parentheses, and your exponents are up high, both of them. Now let's take a moment to look at a question type. So it's easy when they put them all together and you know what the patterns are, because this whole column here is multiplying terms with the same base. multiply terms to the same base, you add the exponents. It's simple when they're all in a row. It's a clue that that's what's going on. Just to remind you, this would be 7 to the 5 plus 6, which is 7 to the 11th power. Here's where it gets tricky down here. So you have your parentheses, and that's why structurally it looks similar to over here, power raised to a power. It looks somewhat similar. But let's take note of the differences, and then we'll get into the practice with the power to power. So the difference is that these parentheses are indicating that this is a fraction, which technically means this is getting multiplied by itself 4 times. Put another way, it means that you're distributing the to the 4th power to both the numerator and the denominator. And not only that, we did this so far. You're then multiplying even further, because now it's times 5/6 raised to the 5th power. So you're going to repeat 5/6 times itself 5 additional times, which we can write out there just to really drive that point home. 1, 2, 3, 4, 5. That's what it means. Obviously, you're not going to do that on a test, but what you are going to do is you're going to keep the base. Keep the base is always a great first step. All of these rules hinge upon the fact that they must have the same base. I'm just going to make these parentheses a little bigger because that could be clearer. Really should have nice big parentheses indicating that that is a fraction, and the whole fraction is getting raised this one to the 4th power. And then our rule is when we multiply terms with the same base, we add the exponents. So this is 5/6 to the 9th power, which checks out when we compare it to all this expanding that we did here. In contrast, here we have power to a power. Our rule is raise the power to a power, multiply the exponents. So this is going to be 7 to the 2 times 3, which is 7 to the 6th. This is 4 to the 3 times -3, which is 4 to the -9. Notice that you do need to know those rules. This one's easy. Positive times positive is positive, but now we've got positive times negative is negative. So those rules aren't going anywhere. Now we have 2 to the -8 times -4. Negative times negative is positive. Gives us 2 to the positive 32nd power. Last one is 6 to the -3. Power to a power, multiply the exponents. This is going to be -3 times 5. The result is 6 to the -15th. One last reminder that has come up a bit in our lessons so far, so I can say it here, is that you could also express this if they required a positive exponent. You could express this as 1/6 to the 15th. These are equivalent expressions. You're allowed to represent it either way. They mean the same thing. Thanks for watching, and stay tuned for even harder questions about exponents and to learn what happens when we don't start with the same bases. What if we have a 32 and a 64? What if we have a fractional exponent? What do we do with that? We're going to check out a question that was very challenging on the May 2023 SAT that touches upon all those subjects.